When dealing with metal-clad cable, specifically with section grounding conductors, electricians often encounter questions regarding proper termination methods. The authority having jurisdiction, or OJ, plays a significant role in enforcing the National Electrical Code, or NEC, and their interpretation can dictate how these conductors are terminated. It is important to understand the relevant code sections, underwriters' laboratories, or all standards and accepted industry practices to ensure safe and compliant installations. Many electricians are directed by the AHJ to terminate the 3 grounding conductors separately, typically using a 3-hole lug. This approach aims to adhere strictly to the listing of the lugs, which are often certified for single conductors only. However, the crucial question arises whether terminating the 3 grounding conductors separately enhances safety or reliability. Some argue that it does not, and that twisting the 3 conductors together might even create a more robust and secure connection. According to the NEC section 250.122, the grounding path must adequately carry the available fault current. The UL standard 1569 lists requirements for flexible metallic conduit, including using section grounding conductors. Furthermore, the Aconite Cable Handbook, for example, provides installation guidelines but may not specifically address the termination of section grounding conductors. Several factors come into play when determining the appropriate termination method. Firstly, connector listings are vital. Mechanical lugs are frequently listed for use with a single conductor only. Therefore, using them to terminate multiple conductors without modification could potentially violate the listing and the manufacturer's instructions. Secondly, equipment grounding requirements are essential. NEC section 250.118 paragraph 10 dictates that the grounding conductor for equipment must be continuous. Twisting the 3 grounding conductors together can be seen as satisfying this requirement by creating a unified grounding path. Thirdly, industry practice on this matter varies. Some jurisdictions permit the grouping of section grounding conductors, treating them as a single equivalent conductor, while others mandate separate terminations for each section. There is no universal consensus. When assessing different termination methods, several key points should be considered. Firstly, adequacy of the grounding path must be verified. The combined cross-sectional area of the section grounding conductors must meet or exceed the minimum size specified in NEC Table 250.122 for equipment grounding conductors, based on the rating of the overcurrent protective device in the circuit. Secondly, the integrity of the connection should be ensured. Regardless of whether the conductors are terminated separately or grouped together, the connection must be mechanically sound and electrically conductive. Torque requirements for set screw connectors should be strictly adhered to. An anti-oxidation compound should be used when terminating aluminum conductors to prevent corrosion. Thirdly, the accessibility of the termination should be maintained. Terminations should be accessible for inspection and testing in compliance with NEC section 110.26. This ensures that the grounding connection can be verified and maintained throughout the lifespan of the electrical system. Furthermore, consideration should be given to the available space within the enclosure or junction box. Terminating 3 separate conductors can sometimes be challenging in confined spaces, potentially leading to overcrowded conditions and difficulty in making secure connections. In such cases, careful planning and the use of appropriate termination methods are essential. In summary, while a definitive consensus on terminating section grounding conductors may be lacking, adherence to the AHJ instructions is paramount. However, if concerns arise regarding the safety or reliability of terminating the conductors separately, it is advisable to engage in open communication with the AHJ, presenting supporting evidence from the NEC and other relevant industry resources. It is also worth noting that alternative termination methods may exist depending on the specific application and the equipment being used. For instance, some manufacturers offer connectors specifically designed for terminating multiple grounding conductors, providing a secure and code-compliant solution. Additionally, grounding bars or terminal blocks can be used to consolidate grounding conductors, simplifying the termination process and ensuring a reliable connection. It is always recommended to consult with a qualified electrical engineer or inspector to determine the most appropriate termination method for a given installation. They can assess the specific requirements of the project and provide guidance based on their expertise and knowledge of local codes and regulations. In conclusion, terminating section grounding conductors in metal-clad cable requires a thorough understanding of the NEC, UL standards, and industry practices. By carefully considering these factors and engaging in open communication with the HA, electricians can ensure safe and compliant installations that meet the requirements of all stakeholders. Moreover, always refer to the specific cable manufacturer's instructions for any specific guidance on grounding practices.